Hey guys, this is Miss Bolin, and today we're going to be going over dividing and rationalizing square roots. Okay, for the most part, most of these 1 through 10 are basically dividing the whole numbers, and so we're looking at them like they're in columns, and then dividing the radical. So as you can see, we have 20 divided by 4, which is 5. And then the square root of 18 divided by the square root of 9, which is going to give us the square root of 2. And we can't simplify that, so that's going to be our answer. So the same thing for number 2. 34 divided by 2 is going to give us 17. And then the square root of 20 divided by the square root of 10 is going to give us the square root of 2. We can't simplify that anymore, so that's our answer. Number 3. 42 divided by 7 is going to give us 6. And then we have square root of 30 divided by the square root of 6. And that's going to give us the square root of 5. And we can't simplify that anymore, so that's our answer. Number 4, 12 divided by 6 is going to give us 2. The square root of 15 divided by the square root of 5 is going to give us the square root of 3. Okay, for number 5, whole number 30 divided by 6 gives us a 5. Square root of 55 divided by the square root of 5 is going to give us square root of 11. That's simplified. Next one, 48 divided by 8 is going to give us 6. And then square root of 42 divided by the square root of 7 is going to give us square root of 6. And that's simplified. And some of you are asking me, how do I know that that's simplified? Well, let's take square root of 6 in the square root, or 6 in the square root of 6. Well, the square root of 6, if you try to break that down, you have a 2 and a 3. You don't have any dates that come out, so it just stays the same. So if you have no dates, it's already simplified for you. Okay, let's move on to number 7. 20 divided by 2. 20 divided by 10 is 2. Square root of 5, we have over square root of 15 over the square root of 5. That's going to give us the square root of 3. Okay, number 8 is a little bit different because we know we don't have a square root of 84 and we don't have a square root of 2. So sometimes with these you can look at these and say, okay, well, can I work within the problem? That means, can I divide 84 divided by 2? Well, if you can do that, then you can leave it as the square root of 42 because 42 times 2 gives you 84. And then we can't break down the square root of 42 anymore, so that would just be your answer. Okay, so we're just looking at this like 84 divided by 2, which gives us 42, which we have a square root, so we're going to keep the square root. Okay, so the next one is 4 over 100, and that you're taking the square root. Well, if you notice, we can work inside, and we can divide both of these by 4 to reduce these. And 4 divided by 4 is 1, and 100 divided by 4 is 25. But notice we still have the square root. So the square root of 1 is 1, and the square root of 25 is 5. So our simplified answer without the square root, because they're both perfect squares, is 1/5. Okay, for our next problem, number 10, 9 divided by 3 is going to give you 3. And then if you take the square root of 20 divided by the square root of 5, that's going to give you the square root of 4. Well, if you notice, the square root of 4 is a perfect square, so you do 3 times the square root of 4, which the square root of 4 is 2. 3 times 2 is 6, so it gives you a whole number of 6. Okay, number 11, you look and you say, okay, the square root of 96 is not a perfect square, and the square root of 12 is not a perfect square. So can I simplify these? Can I say 96 divided by 12? And if I can, what does that give me? Okay, so 96 divided by 12 is going to give us 8. And notice that we have these under square root, so we have to put it under a square root. And when we have this under a square root, the square root of 8, we know that we can simplify this even more. So you can simplify this as 2 and 4, and then 2 and 2. Oh, and yes, we have dates, so we can take out the 2's, and we're left with a 2. So our simplified answer would be, we pulled out the pair of 2's, and then we are left with a 2, so it's 2 square roots of 2. Okay, for number 12. Number 12, you can take 18 and you can divide it by 2, and you get a 9. And then you can also do the radical of the square root of 30 divided by the square root of 3 is going to give me the square root of 10. And that's simplified because you can't break down 10 anymore. Okay, for number 13, you have the square root of 72 over the square root of 2. If you look at these and you look at it like 72 divided by 2, okay, well I can divide those and that gives me 36, but I can't forget that I have the square root. And oh yay, I have the square root of a perfect square, so I can put a 6, and this will just equal 6. Number 14, we're going to do the same thing. We have 50 divided by 5. Well, 50 divided by 5 is 10, and then you have the square root of 40 divided by the square root of 8, and that's going to give you the square root of 5. So that's simplified. Okay, and then 24 divided by this, number 15 is 24 divided by 8, which is going to give you 3. And then the radicals, when you divide them, is going to give you the square root of 13. So you have 13 square root, or 3 square roots of 13, and that's simplified. Okay, number 16. Okay, you have these two, which if you notice, we don't know what the square root of 2 is, and we don't know what the square root of 6 is. And if we try to simplify these, which that means we can divide both of these by 2, then that gives us 1/3. Okay, that's not going to help me because I still have that square root. So that's not going to help me at all. So what I need to do when I'm stuck in this situation is I cannot have at the bottom or in my denominator right here, I can't have a square root. So if I have a square root and I know I can't divide and get something perfect, like say I would divide, if I had the square root of 6 over the square root of 2, that would just equal the square root of 3, and that would be okay because I wouldn't have a denominator. Well, in order to get rid of the denominator, I have to rationalize. And rationalize just means that you're going to multiply the top and bottom by whatever's on the bottom. So if I multiply the top and bottom by whatever's on the bottom, that means I'm going to multiply the top and bottom by the square root of 6. So the square root of 6 times the square root of 6 is just going to give me the square root of 36, which in turn will give me square root of 36 is just 6. Okay, and then on top you have 2, and then the square root of 6 times the square root of 2, that's going to give me the square root of 12. And so you have the square root of 12 over 6. And now you see if you can reduce those. So if I can reduce these, which I would take, and I make this come up here. So the square root of 12, I can break apart to 4 and 3 and 2 and 2. Oh yay, I have dates. That means that I can bring out a pair of 2's, leave in the 3, but look, I still have this 6. So if I still have the 6 underneath, look, I have 2 whole numbers. I have a 2 and I have a 6. Well, what can I do with those? I can reduce them. Okay? How do you reduce 2 and 6? Okay, well 2 over 6, you can divide both of those by 2. And then you get 1 over 3. So instead of the 2 over 6 now, our final answer would be 1 over 3, and then the square root of 3. And that would be reduced. And that makes me happy because I don't have a square root at the bottom. Because you cannot have a square root at the bottom. You can have a square root on the top, but you can't have a square root at the bottom. Okay, if you look at number 17 is going to be set up the same way. You cannot divide those, so you have to rationalize. That means I have to multiply the denominator by the top and bottom. So if I multiply these, when I multiply the bottom, of course I get the square root of 121, which the square root of 121 is 11. And then on the top, when I multiply those together, I get the square root of 110. And I cannot break that down any further, so my answer is just the square root of 110 over 11. And I'm happy because the bottom is not a square root. Number 18. With number 18, the same thing applies. You're going to have to multiply the bottom to rationalize it. Okay, you're going to have to multiply it by the top and bottom. If I multiply all of this out, remember, if you multiply a square root times itself, you're just going to get itself. Don't make that harder on yourself than it is. So you're just going to get itself. Then the top is what you have to really worry about. So the square root of 13, well, 13 times 50, t, okay, that's going to give me the square root of 650t when I multiply it over 50t. Well, now I have to go through and I have to see if I can rationalize this. Well, actually, it's already rationalized. I have to see if I can simplify this. Okay, to save room, what I'm going to do is I'm going to work it out down here. So I have the square root of 50t, and I can break that down by 65 and 10, and then 2 and 5, and then 13 and 5. So as you can notice, I have a pair of 5 CA that I can bring out. And then I have a 13 and 2 that are lonely and they stay in the house. Well, 13 times 2, that is just going to give me a 26. So I will put a 26 here instead. And then I can't forget about my 50t. And my other t goes over here as well. Okay, now I have two whole numbers, which if I reduce these, because these are whole numbers even though it has a t, if I reduce this, 5 divided by 50, which I can divide both of these by 5, and I get 1 over 10. So instead of this 5 that I have, 5 over 50, I'm going to replace it with 1 over 10, which I'm going to put 1 over 10t, which is 1, and then we can't forget about our 26t. So our answer is the square root of 26t over 10t. Okay, so for number 19, you're going to have to rationalize the denominator because you can't reduce this and you can't divide. So that means you're going to have to divide the bottom by itself and the top by the square root of 15 as well. So you'll end up, if you multiply these, with a square root of 105. And the bottom, anytime you multiply a square root by itself, you know you're going to end up with just itself, but not a square root. Okay, the next one we have the square root of 2 over the square root of 17, and we can't reduce that, so we are also going to have to simplify and rationalize. So the square root of 17 times square root of 17, that's just going to give us 17. And then 2 times the square root of 17 is going to give us the square root of 34, because you just multiply 2 times 17, and that's the square root of 34. And that's simplified. Okay, for number 21, as you can see, we're going to have to rationalize this, but let me show you that if you rationalize this, multiplying 48z by 32 is a really big number. It's going to give us a really, really big number. So if you notice, they're both square roots. So we can try to go ahead and reduce this so we're not working with as big of numbers. So if we divided each of these by 4, okay, we would get the square root. We would get the square root of 8 over the square root of 12z. And notice we will still have to rationalize the denominator, but they're a lot lower numbers. Okay, so we would still have to multiply by the denominator on the top and the bottom. Well, if you notice, you end up with 12z on the bottom. And for the top, when you multiply those together, you get 96z. Now I can look at this and say, okay, well, and then I forgot the square root, sorry about that. I can look at this and say, okay, what can I divide each of these by? Okay, I can go even further and divide each of these by 4. So if I divide them by 4, I would have 3z at the bottom, and then I would have the square root of 12z at the top. Well, I know that 12z I can break down further. So square root of 12z. So that's just 2 and 6 and 2 and 3. And I have a pair of dates. Yay, woohoo. And I can pull those out and get 2 square roots of 3. And then I can't forget about my variable. Okay, my variable of 3z. And then I have 3z at the bottom.